the second set of notes is, has to do with rearranging equations, or actually, at the top of this, I want you to add or formulas, because this gets used a lot in science classes. Dr. Spur did this for you at the beginning of the year, because we can't be sure that y'all had all seen it when you came here. But by the time you get to chemistry, your chemistry teacher is going to expect you to be able to do this on your own. So this is one of the skills that's going to transfer into a different class, where you take formulas and rearrange them. So the focus of this is on process. How do I solve? Not what's the answer. I know y'all can all probably look up this right here and know the answer to this. What plus 3 is equal to 12? Anybody know? 9. Okay? You don't have to really do any work. Or you know this answer. What answer is that? It's 15. Okay? Some of it's not so good, but that's okay. This is not going to work with rearranging formulas. You have to show process on formulas. So we're just going to pause for a second and make sure that we understand that when we are solving for x, we're going to subtract 3 from both sides. That's all that I need you to write down. Okay? When you're solving for x on the next one, you're not going to subtract 3, you're going to add 3. You're trying to eliminate something that's in the way. All right? On the third one, you're not going to add or subtract 3. What are you going to do? Divide. Both sides, left side and the right side. And on the left side it goes away, and the right side it turns into something fairly nice. And then this next one, instead of add, subtract, or divide, you're going to multiply. You tend to write it like that. Yes? Okay, on this very last one here, I want to show you 2 different ways that you could do this. Okay? One way requires you to do it in 2 steps. So you multiply both sides by 3, and the 3's cancel, and I get 2x equals 36, because 12 times 3 is 36. And then as a second step, I divide both sides by 2. So it's just making that a 2-step process. That's one way to work it. And then over here we have a little extra room. Copy the problem over again, because I do like to show you a second way to work it that some of you will remember, and it's a perfectly appropriate way to do it. Okay? Does anybody know how to get rid of that 2/3 in one fell swoop? Especially if you don't have a calculator. Multiply by the reciprocal. I know y'all have all heard it. So I multiply by 3/2. And that kind of is like multiplying by 3 and dividing by 2 all in one step. So you multiply by 3/2. Grab your calculator. These cancel over here. And then say 12 times 3/2. And you should get the same answer. 18. And those are both appropriate. These are the 4 things that we do to solve. That's it. Add, subtract, multiply, divide. So far, that's all that we've done. We're going to learn a couple more later, but that's it for right now. And this right here, you have a highlighter. This is what your goal is, to isolate the variable x or whatever variable is in the problem. H, K, whatever we're working with. Okay? Those are your steps. And knowing which one to do is the key to getting these next problems right. Okay? All right. So rearranging equations or formulas that have more than one variable in them. We still call this process solve for x. And that tells you that you want the x to be all by itself, and you want to get rid of anything that's with it. Okay? So what's with x? And by with, when I say with, I mean on the same side. So there's the equals. What's on the same side as the x? Not just a y. Think of the operation as well. What's in front of that y? Plus y. Yes? Okay, so if you wanted to get rid of plus 3, you would minus 3. If you wanted to get rid of plus 8, you would minus 8. So if you want to get rid of plus y, you need to minus y from both sides. And y minus y goes away, and I've got the x all by itself. Isolate the variable. Get the variable by itself. And on the right-hand side, I have 5 minus y. You're not going to get a numerical answer when you're doing this, okay? You're going to get another equation. That's just a rearranging of the formula, okay? Is everybody good with that? So this is about decision making. What am I solving for? What do I need to get rid of? Okay, look at example 2. It's the same problem. But instead of saying solve for x, I said to solve for y. So look at the equation. Imagine the left side and the right side. What's with y that you want to get rid of? A positive x. How are we going to get rid of a positive x? We're going to subtract it. So you have to look at what am I trying to get, what am I trying to get rid of. You do not always get the same answer. That's the simplest case scenario. We'll see that in a few minutes. Okay? Now, a lot of formulas, and these are not formulas, I just made these problems up, but a lot of formulas have nothing but variables in them. Can anybody remember a formula from physics? Any formula? Oh, come, I know you didn't make you memorize it, but yes. Yeah? Yes, uppercase, right? Use that. F net equals MA. Does that got any numbers in it at all? No. And we could rearrange this equation so that it starts with a different variable, and that's what we're practicing, this idea of rearranging these equations. Focus on what you're trying to get to. What am I solving for? X. Solving for X. What do I need to get rid of? Positive Y. So how do I get rid of plus Y? Subtract Y. I like to make my Z's with that little crossbar through them because my handwriting's bad and my Z's look like a C. Right? That's it. You're not going to get a numerical answer. I can't combine those because they're not like terms. But just stop. Just a rearranging of the way the formula works. Same equation. This time I want to solve for Y. So I want to get rid of the X. What have I got? What am I trying to eliminate so that I end up with one variable all by itself, whichever one I've been asked to solve for. Does that make sense, everyone? Okay, so the key is to focus on the variable you're trying to isolate and eliminate everything else using the correct operation. Right? So here's one. I want to solve for M. What do I need to get rid of? P. What is that? What operation is between the M and the P right now? Does everybody see the multiplication, the invisible one? How do you get rid of times? You divide. So we have to divide by P. So this step of picking the correct operation is key. If you add P, that's not going to work. You have to get rid of it using the correct operation. So the P's cancel. I'm going to write it over here just to find it a little bit messy. This is very weird looking 7 over P, whatever that is. Okay? Very weird looking. All right? Almost the same equation, only this time no numbers at all. And this time instead of solving for M, I want to solve for P. Solve for P. So what do I need to get rid of this time? What do I need to get rid of? Everybody. Say it a little bit louder. M. Okay? And how do I get rid of the M this time? Division. The M's cancel, and I get that P is equal to K over M. Does everybody see how this is the same process that you're using with numbers? But you just have to know that your answer is not going to be a number. Okay? All right, so here's a formula that you should have all seen before. G equals RT. What does that stand for? Anybody know? Raise your hand if you know what it stands for. 1, 2, 3, 4. Who would like to tell me what it stands for? And all of it. What does it stand for? Distance equals rate times time. It's a beautiful equation, a beautiful formula. I want you to solve it. So it tells me what R is. Okay? What do I need to eliminate? T. Divided by T. And R is equal to distance divided by time. The rate is your distance divided by your time. These two formulas are equivalent. They're the same. All right? But sometimes one's easier to use and sometimes the other is. Okay, example 7. We are solving for H. There's the H. What am I trying to eliminate this time? What needs to go? The G. All right? So am I going to add it, subtract it, multiply it, or divide it? Multiply. It says divided. I need to do the other thing. So don't put divided by. Make sure you put multiply. And G on top and G on bottom cancel. And I get H equals K times G. Okay? Pretty easy? Yes? Okay. So sometimes in solving equations, quite often we have to do more than one thing. So let's think about the process of these two problems. I don't want you just to write answers down. I want you to think about the process. here's the x. You have to get rid of the 2 and the 5. Which one do we get rid of first? The 5. So that's what we do in a few minutes when we haven't got so many numbers. We're going to get rid of that minusing thing first. We add 5 to both sides, and then we divide both sides by 2. And we get a number. Okay? The process we're going through. All right? In the next one, what do I get rid of first, the 3 or the 4? The 4. So subtract 4. We need to not mess up on our arithmetic. -9. And then we need to do what to get rid of the 3 this time. It's already divided, so don't divide again. If it's already divided, what do you need to do? Multiply. Is everybody saying? That's one of the most common mistakes, is to say, oh, it says divide, and to go over and divide the other side. It's already divided, so I need to do the other thing. I need to multiply. The next is going to be -27. Okay? So we are now going to apply this to some equations that have not got so many numbers in them, that have got more than one variable. In fact, sometimes they don't have anything but variables. Okay? All right, so I'm giving you the instructions here, but you should be able to look at this and say, I want to solve for x. I need to get rid of the y and the 3. If that y were a number, like if it were a 2, you would get rid of the 2 first. We're going to get rid of the y first by subtracting it from both sides. When it's all numbers, you can actually add them or subtract them. Here, I get 6 minus y. I cannot combine those because they're not like terms. Okay? All right, what's the next step? Divide by 3. Now here we're going to have to look at a couple of different ways to write your answer. And I'm going to expect you to be able to do both things. They're both useful. One, just write it down exactly like it's written. 6 minus y, all of it divided by 3. It's a perfectly good answer. But I also expect you to be able to break that apart into 2 pieces. We practiced this back in the fall. So I expect you to be able to break it into 6 over 3 minus y over 3. You remember us doing that? Yes? And reduce anything that you can. What is 6 divided by 3? 2. And then we usually, instead of y over 3, we usually write 1/3 y. Like that. Does everybody remember doing that? Both of these answers are fine. This is a good answer. This is a good answer. I expect you to be able to do both of them. Okay? We will practice doing both of them. All right. I think this is the same problem, but this time instead of solving for x, I want to solve for y. It's the same question, but I'm solving for something different. So what do I need to get rid of? Again, keep in mind what's the left side and what's the right side. What am I trying to eliminate here? The 3x. Does everybody see it? How do I get rid of a plus 3x? Subtract. I'm going to pause right there to make sure there aren't any questions. To frame that differently. Are there any questions? Are we good? It's all about choosing the right step and then executing it correctly. Okay, number 10, we're going to solve for x. All right? So we don't want to start by dividing by 4. We want to get rid of anything that's added or subtracted first, just like we do when there's all numbers. So you get rid of the 3y by adding the whole thing. 3y, just like that. I should also point out that some people really hate having the variable at the back of this. So if you like this better, you could turn that around and say 3y minus 12. Can y'all see that that's the same thing? If that makes you happy, that's not going to be a big deal. Okay? Either way. And then we need to get rid of that 4. So we added something and now we're going to divide by 4. This is a perfectly good answer, just like it is. There's nothing wrong with it. But I want you practicing rewriting it by actually doing that division and reducing. And again, you can use your calculators to help you. You've got to do -12 divided by 4, and you've got to do 3y divided by 4. Sometimes you'll need your calculator, sometimes you won't. I think all of you can say 12 divided by 4, right? What is it? 3, so this will be negative 3. And then this 3y over 4, we typically write that as a 3/4 y. This is leading us into our unit on graphing that's coming up. Do y'all remember graphing last year? Does anybody remember y equals mx plus b? Does anybody remember that? This is leading us into being able to do y equals mx plus b. Okay, so let's try this next one. We're almost done too. This next one. 4x minus 3y equals negative 12. What are we solving for? Always make sure you know what you're solving for. So what is it I'm trying to isolate? The y. So what is it I need to get rid of? I need to get rid of the 4x, and I need to get rid of that divided by 3 at the end. Which one do I get rid of first? Okay, careful, ladies. Everybody careful. Did that say minus 4x? This is a positive 4x, yes? So we get rid of it by saying minus. Make sure that negative gets carried down, negative 3y. Got a lot of negatives in this problem. Okay, and then we're going to divide by negative 3. Okay? Now, would y'all take that to the next step when you break it apart into 2 pieces? Use your calculator if you need to. Break it apart into 2 pieces and reduce anything that you can reduce. Negative 12 divided by negative 3 is 4. And be careful, this one kind of gets lost. Y'all see that minus and that negative right there are going to come together and make a plus right there. And that's one that's easy to lose in the translation. And then we're going to write that as 4/3 with the x on the outside. Okay? 4/3 with the x on the outside. All right? Okay, if you look through the rest of it, you will see that you have many. I skip over the ones with just numbers and oh. I got 2 more examples. Did these get stapled wrong? I got 2 more examples. My next page says homework. Does y'all's next page say homework? Oh, does your next page say example 12? Oh, good. Just mine. Let's do example 12. 2 more problems. Or 3. Yeah, 3 more problems. Okay. So I've given you the steps. Go ahead and see if you can try do the first step on this problem. Make sure you know what you're solving for. Did I get the right first step? There's several things you can do here to get rid of this 1/2. One of them is to divide by 1/2, and that's a pain. I hate dividing by fractions. It's like I'm just always making mistakes when I do it. So I'm going to go with the other one. We just did it a little bit earlier. I'm going to multiply to get rid of 1/2. I'm going to multiply by 2/1. Notice the use of parentheses on the right-hand side. You have to multiply everything times 2. Everything in the problem has to get multiplied times 2. On the left side, you get x. On the right side, you get 6 plus 2y. Does anybody have a question? We good? Okay, same problem, but this time instead of solving for x, we're going to solve for y. So you make a different first choice. Solving for y, so we want to see if we need to add or subtract anything. Subtract 1/2 x. And make sure that negative gets carried down with the y. This negative right here has to get carried down with the y. And for some reason, people tend to forget this last step. That's got to say y equals, and it says negative y. But dividing by negative 1 is super easy. When you divide by negative 1, all you do is change the sign. You just change everything's sign. So instead of negative y, we're going to get y. Instead of 3, we're going to get negative 3. And instead of negative a half, we're going to get, sorry, a half x, we're going to get plus a half x. That make sense? Here, a little frown. Okay, about which step? All right.
Well, I did times 2 of the 1.
At the beginning?
Yeah.
Okay, so you started this problem by multiplying everything in the problem by 2? Like that? All right, so that gives you x minus 2y equals 6. Yes? Okay, you can do this, this will work, and it's not a bad technique. We talked about multiplying to get rid of fractions earlier. If you use it correctly, you should still come up with the same answer that I did. Okay, so why don't you leave it like that, and let me come look at it in just a minute. All right, so let me see, what was the answer at the end? Y was equal to?
Negative 3 plus a half x.
Yeah, negative, thank you, negative 3 plus a half x. Okay, so just mark it there, and let me come look at it in a second. Okay, there's number 14. Now, the thing that strikes me about number 14 is that there's not any numbers in it at all. Not a single number in the whole thing, okay? So, zero in, focus in, what am I solving for? What does it tell you to solve for? H. You gotta get rid of A, B, and G. Get rid of all of it. What are you gonna get rid of first? Something by adding and subtracting. So what are we gonna subtract first? A and B. It's like one thing. It's an A, B. It's a whole clump together. It's called a term. We're gonna subtract the A, B. And I can't actually put those together. K minus AB is K minus AB. There's nothing to be done to that. They're not like terms. All right? And then your last step, or your next step, is to get rid of the G. And how are we going to get rid of the G? Divide. Okay, divide both sides by G. And H equals K minus AB over G. This is a perfectly good answer. There's nothing wrong with it. Or you can take it into its separated form, which is K over G, K divided by G, minus AB divided by G. There's no difference in those two. They're both good, and sometimes when you get to algebra 2, sometimes you're going to want this one, and sometimes you're going to want this one. It just depends on what you're doing with it. Okay? All right, now look ahead, and I think you'll see the homework. Yes? And it's just 2 pages, I believe. 1 through 16. Okay? All righty.